to do facial recognition and facial identification. So what facial recognition is really just pulling out faces in an image or a video. This technique that we're going to show you works for both of them. And since OpenCV is so powerful, it's actually really easy to implement. So we're not actually going to have to do a whole lot of work. Yes, there's some understanding on how to actually get it set up, but once you do, it's going to be very useful and easy to get going to recognize faces. Now, that's not the same as identifying faces. Identifying faces is what you see now. That's a bounding box around my face with my name on it, right? That actually shows that we can actually identify faces in a video or image as well using OpenCV. This takes a little bit extra training that we have to do. So at the end of this, we'll have two different Python modules, one that's dedicated towards training and one that's dedicated towards not only recognizing but also identifying faces in a video. Now, the training portion and the recognizing or the identifying of a face, those things can absolutely be advanced, but OpenCV has some built-in features to make these things a lot easier. And when I say advanced, I mean by using like a deep learning library such as TensorFlow or PyTorch. Those can advance our recognition feature for the identification portion. Now, if all this stuff sounds a little confusing, you might want to go back and learn a little bit more about OpenCV. But if you know OpenCV and you have it ready, let's go ahead and jump in. And if you don't have it actually installed and ready, but you want to jump in, check out the description below because we actually show you how to get your system set up with OpenCV. So without further ado, let's actually jump into the code. So I have a new file here called faces.py, and I also have some images in here that I'm going to be running at some point. So to get these things, the faces.py is based off of base.py, which is on our repo, right? So this is the repo itself. And of course, if you go to joincfe.com/GitHub, it'll take you to the repo and you just want to look for the OpenCV Python series. And inside of SRC, you'll see all the things in there, including the final code for this once it's there. And you also see that I have those images in here by default. So we'll go over to those in just a moment. But the thing is that we first and foremost need to do is we need to get the built-in har cascade classifier. So this is something that's relevant to actually identifying a face in any given frame. Okay, so inside of faces, let's just run an example here real quick to make sure that we've got everything running. I'm going to go ahead and go into my dev folder, into OpenCVTube, and I'm going to go ahead and activate it. Oops, /scripts/activate, and I'll do pip freeze just to make sure I've got everything installed. Notice I have Pillow installed. That's something that you will want to install if you don't have it. So pip install pillow -- upgrade. And of course, OpenCV and NumPy are other things that you'll want. Okay, so yeah, I did a typo there, but you'll want to make sure that you have Pillow installed. Okay, so now let's go ahead and just run inside of SRC. We're going to run Python faces.py. I just want to make sure that my system is actually allowing for my frame to look and work, right? So Python faces.py should actually run my commands in here. So again, I'll save that and run it one more time, and there we go. So now I've got my frame open. This is the webcam that I'm using as I did with the intro. Same thing, right? But of course now it's driven by OpenCV and not driven by Camtasia, which is the recording software I'm using. So just a cue to quit it out, and now we've got our base ready. Now we're ready to actually bring in those cascades. Now, depending on when you're watching this, or actually probably by the time you're watching this, the cascades will actually be in this SRC folder. So if you have any issues with what I'm about to do, you can actually go onto the OpenCV source and grab it from there. The reason I wouldn't do that is because if OpenCV updates these, the ones on my repo most likely won't be updated. So you want to go off of the default ones. And when I say default ones, I'm talking about files here. It's really, really simple. So let's jump into Python, the Python shell, and we're going to import CV2. And then I'm just going to go ahead and print out CV2 period dash underscore underscore file underscore underscore enter. This is where my OpenCV is located, right? So it's in my site packages. No big surprises here. I'm going to now exit out of Python and I'm going to navigate to the root of this. So not with that last portion, whatever that is. I'm going to go ahead and copy this and we're going to bring this into our actual file finder. So I'm going to copy that open and open up the file explorer, excuse me. And I'm going to go ahead and paste that in there. So if I hit enter, this is what I see. Now, Mac users, it's not a whole lot different. Actually, Mac users, you can probably just do open, Mac and Linux, open, and then whatever that path is. So all the way to CV2, and then open that path, and then you'll see something like this. So you can do a symbolic link, or you can actually drag this folder in and copy it. So that's what I'm going to do. I'm going to drag this folder in and copy it into where my project is. So my project's in dev, it's in OpenCV2, SRC, and I'm going to make a new folder in here called Cascades. So Cascades, and inside of Cascades, I'm going to bring in this data folder that's in OpenCV. So inside of that data folder, you should see har Cascades. You should see all of that stuff. I'm just going to bring that entire thing over, and we're going to copy it. So copy it over. Whatever system you have that you need to copy it over, just copy it over. That's one quick way to do it. We have all these XML documents in here now. So we have the har Cascades ready. Just to recap, we went into the Python shell right here, and then we imported CV2, and then we opened up where that location was by printing out where it is with underscore underscore file and underscore underscore. This is a really useful way to find where any module is, let alone the one that we're working on. Okay, so now that we've got that, let's go ahead and back into Sublime Text where our code is, and we see that we have our cascades in here. Great, I'm actually not going to change anything about that data, but instead what I'm going to do is start writing out various paths that I want to use. So I'm going to open up my sidebar a little bit here and take a look at these things. Actually, I'll go back into my data for CV2. In my cascades, I'm going to just go in here so I can zoom in a little bit easier so you guys can see it easier as well. So we'll view this as a list. It might not let me zoom in there. Yeah, so it's not letting me zoom in with the names. Okay, so unfortunately I can't zoom in with the names, but basically what we want to do here is I want to get the frontal face, something in the frontal face in here, right? So you're going to want to play around with these in general. You're going to want to test out different ones to see how you actually can grab the face or the facial features differently. So the one I'm going to go off of is this Alt2 one. It's just one that I tested, and I'm just going to use that specifically. So above cap, I'm going to go ahead and just say face underscore cascade equals to cv2 dot cascade classifier. And this is going to be in the string of cascades slash data slash har cascade underscore frontal face underscore alt2 dot xml. Okay, so if you had any typos or type errors at all, like actually typing this stuff out, this is where I just moved everything, right? So looking back in my data, my SRC folder, if we go here, we are identifying cascades for this directory. And then of course data is that one. And then finally, the name of the file is the one that's in here. So if we view it by a list, it's one of these file names. So I used alt face or frontal face alt2. So I can quite literally copy and paste that in there, but it looks like I typed it fine. So now we just need to actually use this face cascade and detect the faces in this frame. But before we do that, we actually have to convert the frame to being gray. This is how this cascade works. So you have to use it off of gray. There might be another way to do it, but as far as I know, it's off of gray. And that's from the documentation and everything I've read about it. So we want to put it into grayscale, and we go ahead and do CV2, convert color, and of course it's the frame, and then CV2 dot color, obviously all these things capitalized, BGR to gray, and that's now our gray frame. So we're going to use that to find all the faces in this in this frame. So whether it's a video or an actual picture, we'll do faces, face cascade. So of course what we set here, dot detect multi-scale of gray, and then we can take in the scale factor. I actually think the scale factor, if you scale it up a little bit more, it might be a little bit more accurate, but this is where we're going to play with these numbers, but going too high ends up being potentially a problem. And then we do min neighbors, min number of neighbors, and I'll say 5. This is going off the documentation. I believe the documentation is exactly like this, 1.5 and then 5. Again, you can play around with these numbers if your results aren't as great as you would have hoped. So now I can actually iterate through these faces. So well, this is going to be the X, Y, W, and H values in faces. So I'll go ahead and print those things out first. So print X, Y, W, and H so we can talk about them. So let's go ahead and save it, and let's go ahead and run it. And what you see on the left-hand side here is all of the values where my face is. If I remove from it, it stops moving. And you probably couldn't hear me that well, but when I'm not there, so if I cover it up, it stops moving. So those numbers are gone. And then as soon as it starts recognizing again, it sees it again, right? Cool. So what's happening here, I'm going to go ahead and close out that frame, is something called a region of interest. So ROI. Yes, that sounds like return on investment, but it stands for region of interest. So that means that my face is actually showing up in this frame. Now, if you're concerned or thinking like, why isn't it gray? We converted it into grayscale. Hopefully you remember back to when you actually display the resulting frame, I'm still displaying the color one, even though I'm detecting things in the gray one. So what that means is my region of interest for gray is equal to gray and the location of this frame. So the location of this frame is as this. So y equals to y plus h. I'll explain this in just a second. X colon x plus w. And we can actually save this image. So I'll just go ahead and say image item equals to my-image.png. And then we'll do cv2.img, im right, not img. It's a common mistake that I make is img right, because I'm so used to writing img myself. You might not be, but so img item and then ROI gray. Okay, so if I save this, what's going to happen after I run it is it will actually save just my face. So just the portion of my face that's actually showing up. It will remove everything else. So let's go ahead and see what I mean by that. If I look at my image, there it is. There's me looking to the side. Now let's try it again. And we'll run it. This time I'm going to look at the camera and try and close it out at the same time. There we go. So now it should have a little bit of a different one, and it does. So granted, with this same call, I could actually write a ton of images here. I could write my face multiple times, which might be something that you end up doing in the future. I'll leave it just as that so you guys can see that. But this is my region of interest for only the gray frame. But since the gray frame, or the grayed out frame, the grayscale frame, and the actual color frame are the same, I can do this same thing twice. One is the region of interest for gray. The next one is the region of interest for color. And that just takes in, instead of gray as the frame, it's going to be the frame. Okay, so what's going on in here has to do with the actual pixel values for that item. So the pixel values are taking the y value and the y plus h. So the actual square that's in there, right? So y plus h means where it starts at y, so the x and y axes, and then it adds h, and that's the bottom part, right? So then the X starts with the left side of it and then adds W and goes to the right side. So that gives you those two coordinates. So it's basically saying coordinate, in other words, let's say coordinate 1 as far as height is concerned, and then coordinate 2 as far as plus height, right? So that's the Y value. That's what's happening here. Or it's probably better to have it in parentheses than anything else. So, and it's starting at some X or Y coordinate, right? So in this case, it's Y coordinate without height. So we'll just say Y coordinate start, and then this is Y coordinate end. And you could say the sort of same thing for X too. It's the exact same. It's just taking into account the height and the width. That's it. Okay, so we now have our region of interest. So all we have to do now is actually draw a rectangle around it, or something in the frame. I want to actually have a rectangle. So to draw a rectangle, first thing that I want to do is declare what color I'm going to make it. And that color is 255, 0, and 0. And this is not an RGB like you might be used to. For whatever reason, it's in BGR. I'm actually very interested to know why it's this way. But BGR, of course, is blue, green, red. And it's the values of 0 to 255. So 255 means it's totally blue. And then 0 and 0 means all it's going to be is blue. So you put those three together and it comes to a new color. If you're interested in those things, please let me know in the comments. I'll check it out. And then finally, we want to have our stroke. So how thick do we want the line to actually be? So I'm going to give it a stroke of 2. You can change it to 20. You can experiment with both of those numbers to see the results yourself. And then finally, cv2.rectangle. We are going to grab the frame. So we want to draw the frame, or we want to draw on the frame. So I'm drawing on that original color frame. Of course, I could do the gray frame if I wanted to. And then after that, we want to do the starting coordinates, which are X and Y. And then we want to say how big it's going to be. So how wide and how tall. So, width and height, something like that. So width, what's width? Well, it's going to be equal to X plus W. And then what's height? It's going to be equal to, height is equal to Y plus H. Okay, so this is giving the actual coordinate of those places. So this is really the starting coordinate and the starting coordinate for X and Y. And these are actually the ending coordinates. So I'm going to change it back to being in chord and in chord X and then in chord Y. Just for my own reference and as well as yours. So it's not actually the height and width, it's the coordinates. So we have starting coordinates and then ending coordinates. And with the rectangle, OpenCV knows that it's going to draw a rectangle. It might turn out to be a square. It might turn out to be an actual rectangle. It might be something different than that. So that's how we would draw it. And then we add in our color, so color, and then our stroke. We save that. And this right here draws that rectangle on that frame. I don't have to do anything else. So I can go ahead and save it and run it again. And now what we're going to see is actually a color of blue where the region of interest actually works. Notice that it does cut out. And that's because our classifier won't get everything, right? It's not perfect. So when I'm turned like this to completely profile, it's not working. Why is that? Well, a big part of it is, I said, frontal face, right? So the HAR Cascade classifier that I used is frontal face. So it's looking for the front of my face. It doesn't have, or I'm sure it probably does have one, or there's probably one out there that does profile, and actually it does right here, the profile of my face. So you betcha I could have both of these things working at the same time. Not something I'm going to cover just yet, but I do have now a lot of really cool stuff going on with this actual frame. Great. So now what we need to do is recognize these frames, or recognize what's going on here. So we have our region of interest. Now how do we recognize this? that's the big question, right? Well, what this means is we have to have some sort of algorithm or some way to recognize that region of interest. So luckily for us, OpenCV has the ability to train a recognizer. But this is where we could use a deep learned model to predict things here as well. So if you're familiar with Keras or TensorFlow or PyTorch, or among other things, you could use scikit-learn too. Basically, you would be looking at this as, how do we recognize this? Well, there's a lot of different methods on how we could identify who this person is, right? So what OpenCV did was use this HAR classifier to say, hey, there's a face right there. Now we just need to figure out, how do we actually recognize who that face is? How do we identify who that person is? And obviously in my case, it's Justin, but we might have other faces that end up in our frame, and we might want to try and attempt to recognize them. Now, what I'm about to show you is not foolproof. It doesn't work perfectly, and I think there's a lot of downsides to using it, but the main thing here is it actually works, and it's really not that complicated. Where when you want to start talking about putting in a Keras trained model, it might start to get a lot more complicated. I mean, it does. It actually does. Once you start getting deep learning in there, it does get a little bit more complicated. But we will probably cover something related to that. So make sure that you subscribe to get everything and know about it, and hit the bell for notifications when that thing actually drops. So we will most likely do, or not most likely, we are going to do something with Keras and OpenCV. So stay tuned to that. Well, in the meantime, let's go ahead and implement our own. Okay, so I'm going to go into my SRC folder here, and I'm going to make a new file, and this is going to be called faces-train.py. And in here, I'm going to actually have to do several things that is related to my images. Okay, so right now would be a really good time to download those images or images of people. So if I go here, Peter Dinklage, he plays Tyrion Lannister on probably my favorite show, Game of Thrones. And here are some pictures of him. So a quick Google search for Peter Dinklage face gave me these things, right? So that's true for Jaime Lannister as well. I've got several pictures of his face, and Kit Harington. All of these are Game of Thrones characters, right? And then Emilia Clarke. Right, so basically I have all of these different characters, and then I have pictures of me. These are just various pictures of me that I've used, and they are over the years. As you see here, I don't have a beard there. So what I want to do is take all of these images and make something out of them. I want to actually first see all of these images and start to turn them into trainable data. So that means that I'm going to have to go into import OS, and I'm just going to be opening my image directory. So this image directory here is right there. If you're already familiar with this method, you could probably skip this portion, but for those of you who aren't, what I'm doing is I'm going to be literally walking through the directory, looking for either PNG files or JPEG files, and then adding them to some sort of list that I'll end up training. Okay, so we're going to go ahead and say base dir equals to os.path.dirname, and there's going to be os.path.abspath file. Okay, so if you've never seen this call before, basically what I'm doing is wherever this file is saved, this current Python file, I'm looking for where that path is. That is the path on my actual system. In other words, right here. So if I, bring this over, this is the path, right? So this is part of the path, and then that's the final path with faces train in there. So again, going in the properties even further, I see that the location is here, and then the path or the actual file would include that final location. So I actually wanted the directory, so that's what ospath.dirname does. It gives me this value, whatever that value is, and it's true for any system. That's why I have it. It's true for every system. So if I move this over to a Linux server or a Linux computer or a Mac computer, that base dir will be the same. Wherever that file lives, that's where it is. Okay, so then I want to get the image dir, so the image directory with ospath.join, and this is going to take in that base directory and give me the images. Really simply, it's just looking for this folder right here. If you have a different name, you're going to want to change that. So next, I want to actually see those images in there. So we'll just go ahead and do for root dirs files in os.walk and image dir. So I can then, inside of this for loop, I would do for file in files. This would iterate through the files in there. Then finally, I'll say if file.ends with PNG or file.ends with JPEG, then I'll actually print out the path of this file. So I'll just say path equals to os.path.join root and file. So let's go ahead and print out that file, or that file path itself. So I'll save this and we'll go back into my PowerShell here, and I'll just do python faces-train.py, and I hit enter. I get all of those images. Now, the key thing with how I have this set up, I have this set up basically have the folder with that person's images, right? So that's important. That's actually very important to how we're going to do this, because in a moment, I'm actually going to get the label of these images. So the label meaning, all 6 of these images are Justin. The actual file name is 1, 2, 3, 4, 5, 6, but the label is the actual directory. This is actually common practice. So you'll see this in other areas as well of machine learning. So basically I'm saying, hey, this is the folder that holds all of Justin's images. So eventually what I'm going to do is every image for Justin has the label of Justin. And then the image itself has whatever file name. The file name doesn't matter in this case. Now this is for a computer. It's not for us humans necessarily, but it's for a computer. So I only named them 1 through 6 because to me that's a lot easier than some random thing from the internet, right? So these did have random names from the internet, but I just changed them to being 1 through 6. Another thing to note is they are not all the same size. They're close, but they're not all the same. Something that's kind of cool as well. Okay, so now how do I actually grab from this path, how do I grab the name of the folder that it's in to give it a label? Well, it's actually really easy. We say label equals to os.path.base name and then the directory name of this path. So we'll say os.path.dir name of this path. Now we can probably use root, but I'm going to just double check and make sure that I'm just going off of path. I can probably, in other words, I can probably put root in here. So we might do both of those. But another thing that I want to do is I want to make sure that I'm replacing any sort of space with a dash. This is mainly for you if you accidentally name the directory incorrectly. And then I also want to lower case everything on that label. So now I'll go ahead and do print label and path. We'll save that and we'll run it. And now it's showing me the label and the path. Great. So the label, let's go ahead and just try that with root. Let's see if that's the same. We save that, we run it, and it turns out to be the same. Now, why did I show you that? I just wanted to show you that, yeah, sometimes you might see code that's a little bit more complex than it needs to be. So, yeah. And with replace and lower, this is just a safeguard. It's probably not the best safeguard because you might need to clean it up even further. But in my case, I'm not going to. I'm not really worried too much about the label. You could run into issues with it, but again, it's not that big of a deal. Okay, so now I have a label and a path. So I want to keep these things. So let's first say x train and we'll equal to an empty list. And then we'll say y labels and we'll put that equal to an empty list. So intuitively, I would just go ahead and say, you know, xtrain.append path and ylabels.append label, right? That's my intuition. That's what I would end up doing. But really, we don't want to do that. What we want to do instead is we want to use a number value for our labels. So some number for our labels. And then also I want to, you know, verify this image, and I probably want to turn it into a NumPy array. You might not be familiar with this portion, but we do want to do that. And we also probably want to convert it into gray. So we probably want it to be a gray image, much like our actual cascade and all this stuff is going on, right? So that means that I have to do additional things with these images. So I actually don't want to append these here just yet. So instead, what I'm going to do is say, I'm going to give a pill image, and this is going to be image.open of the path. So I need to actually grab pill. Pill, of course, is the Python image library. So we'll do from pill import image. And if you don't have it installed, which I think you do because we've talked about it, you just want to do pip install pillow and make sure that pill is installed there. And this will now give me an image of this path. And again, I made sure that the file extension ends here. And I'm not really worried about exceptions necessarily. There might be exceptions that come up. In other words, if it's not actually an image, but it does end with JPEG, that does run an exception. That causes a problem. But what I'm going to do is just convert it into L. So .convert L turns it into gray, or grayscale rather, not just gray, but grayscale. And then the image array. So now I'm going to convert it into a NumPy array by importing NumPy. So we'll import NumPy as MP. That's a common designation for NumPy. So we'll do mp.array, and we'll bring in this pill image, and we'll use uint8 as the type. So we're turning this into a NumPy array. We're doing a lot of stuff here that like might be outside of what you're normally used to. So let's just look at this image array just like that. So we'll save it, and let's go ahead and run it. Oops, we don't need to install it. We'll just run it. And this is the NumPy array now. Okay, so this is taking every pixel value and turning it into some sort of NumPy array. So every pixel's in here, and it's now into numbers. So I basically just converted our image into numbers. It's pretty cool because like if I open this, it's an image, right? It's showing me an image. But now when I printed it out, it actually shows me what is in that image. It shows me the numbers that are in that actual image. So this is what we want to train on. This is actually a very common thing to do. And if it's like a little complicated, I understand, that's okay. It does get a little bit complicated here as far as the array is concerned. And if you're really, really confused about this, let us know in the comments below. Otherwise, just kind of stick with us and just bear with us on the understanding of these two things. But essentially, every image has pixel values. What we did here is we turned them into first the grayscale, and then we turned that grayscale into a NumPy array. So we converted it into grayscale, and we use that as a list of numbers that are related to this image. And with that, then we can actually start training it. So before I can actually start training it, I want to actually know the region of interest for this image. So that means that I need to go back into my faces array, like where I'm going to be doing the prediction. So I'm going to go ahead and grab this face cascade and use the same thing here. So I need to import CV2 as well. So let's import CV2. So we have our face cascade again. And then we are going to just go ahead and say for, or rather we need to do our faces, and that's going to be our detector, which is our face cascade. So face cascade dot detect multi scale. And honestly, we could do it the same way as we were doing it, like with the same scale factor, but you really don't have to. So I could literally copy and paste that whole thing, and we could do that whole entire thing, or we could just get rid of the scale factor and the minimum neighbors to whatever the default is. That actually might be what the default is. I actually don't know. You'd look in the documentation to find that out. But now what we do is just this image array. See, when we actually capture it in CV2, CV2 or OpenCV already has it in a way that that face cascade could do it, right? So when we open it up in CV2, I believe it's already a NumPy array, which we could test out by printing out the frame. But what we have here now is we are taking it to gray, we're putting it into a NumPy array, and then finally we're actually doing that same face detection inside of the actual image, because we still need to detect that image. So now we can just go ahead and say for, again, X, Y, W, and H in faces. We can grab the ROI, so the region of interest, I'll just leave it as ROI, of the image array. And we're getting the Y value all the way to the Y plus H, and then X value all the way to X plus W. And that we want to append to xtrain.append, and we'll append the ROI. Okay, so now we have our training data, except we don't have the labels or the actual person that's associated with this region of interest. See, we want to take our labels because we know them. This is all about the known values, and we want to associate it with this training data now. So we want to do that using an ID. So we actually want to grab whatever ID would be here and bring that into our Y labels. So I don't have any IDs. So how or what would be a good way to do this? Well, I want to create the IDs in with this label. So I know what the label is, but I don't have a number value associated to it. So one of the ways we can do is just say current ID equaling to 0. And then for every new label that is created, or every new label ID that is created, we would add 1. So in other words, we need to create a dictionary that says label IDs, and we're going to put it equal to an empty dictionary. Okay. So now when I iterate through all of this, what I want to do is I want to say, we're going to say not for, but rather if label in label IDs. So if it's in this dictionary, then we'll do something. For now, I'll just say pass. Otherwise, like the default for most of them, it won't be in there. We'll do label IDs of the label equals to whatever the current ID is. And then I'll just go ahead and append the current ID right away. So plus equals to 1. And then finally, I'll just say the ID is actually equal to that value, right? So what this value is. Okay. So that also means that I can just go ahead and, well, tab this back, right? Because if it's in there, then we will set it to that. If it's not in there, then we'll add it in there and then give it a current ID or whatever that current ID number would be. So really I can just say, instead of if it's in there, I'll just say if not label in, then we actually create a dictionary with the label or the person's name and an ID associated to it. This is just a way to do that. And another way, we could actually just look at this and we'll print out label IDs so we can see it. And then what I'm going to do is, now that I have an ID for that label, which is this right here, I can actually do Y labels equal dot append that ID and keep that underscore there too. Okay, so why is it that I can do this? Well, if there's 10 faces in here, I have a label for it. Now, again, my faces don't have 10, they have 1. So more than likely, you won't have multiple faces. You shouldn't in these images. You should not have multiple. You should have 1 because we're identifying that one single person. That's really important for the training. Okay, so let's save it. And then in the final thing, we'll just go ahead and print out Y labels, and we'll print out xtrain. Let's save that and we'll run it. And of course, it's giving me so much stuff. Like it gave me a bunch of things printed out. So I'm going to comment out these printed stuff in just a moment, or for now. So we save it and I run it again. And what I see here is, look at this dictionary. So I've got Amelia Clark, Justin, Kit Harington, and so on. It gives me the number value that's associated. So I actually created an ID for all of these labels. That's awesome. That is really, really useful for us. Okay, so what I need to do now is actually save these labels so I can use them inside of faces.py. So let's go ahead and do that. I'm going to do it by importing something called pickle. So import pickle and scroll down to the bottom. After all of those things are parsed out, they're identified, they're put into basically a list of numbers, right? So one has the numbers of the actual pixel values, which is this, and another one has the actual numbers that are related to the labels. Once all that stuff is done, then we're going to go ahead and do something like with open, and I'm going to call this labels.pkl for pickle, and we can actually name, I think you might be able to name pickle items anything. I think probably we should just call it pickle. With pickle, labels.pickle, WB as in I'm writing bytes as file, or F, pickle.dump, and we're going to dump in the label IDs to that file. So the label IDs, again, are all of these label IDs, and we need those because when we run the prediction, we want to be able to get what those things actually are, what the label actually would be. So that's something that's important. All right, so that's pickle. And now that we have the label IDs saved, now all we need to do is actually train the item itself, which we haven't built in yet. So now we'll go ahead and make our facial recognizer. There are a few different ones, but I'm going to be using the LBPH face recognizer. From the tests I've done, this one worked pretty well. So I'll go ahead and say recognizer equals to cv2.face.lbph face recognizer underscore create. There we go. So this is our recognizer. I actually don't have to put this up here, but I am because this is where I'm declaring a lot of things. And then down here at the very bottom, we can actually use recognizer.train, and we're going to do xtrain and then a mp.array of our labels, which is ylabels. And then finally, recognizer.save, and then I'm just going to call this trainer.yaml, that's how you would save it. So a couple things here. You want to put the training data, which is the actual image arrays, so the NumPy arrays that are coming through from here, from this region of interest. And then we wanted to just convert our ylabels into NumPy arrays as well. I actually am not positive if you needed to do this here. You could have done it somewhere else. But now we would have our recognizer, and then all we need to do now is actually run the training. So I'm going to get rid of these print statements altogether, and we'll save everything. And let's go ahead and run it. So make sure you save everything. And we just run python faces-train.py. And looks like I have a typo. Recognizer. There we go. Try that again. And this is what you should see. This is the actual training, and it's done. So now what we need to do is just implement this recognizer. And there's a couple things that we need to consider here. When I jump into faces, well, how is it that I'm going to use this recognizer? Well, first and foremost, I probably need to bring in the actual recognizer itself, right? I need to initialize whatever recognizer I'm using. Of course, this could be another trained model. It doesn't actually have to be this OpenCV recognizer, but that's what we've been doing, so that's what we'll stick with. And actually, I want to reorganize how I did this. Okay. There we go. And then the next thing would be actually bringing in our trained data, right? So we want to add in recognizer.read. And of course, we called it trainer.yaml or YML. So we now have a recognizer and we can run predictions on our item. We can actually predict things now. So let's do that. I'm going to scroll down to where our recognizer is. And the predictions are ID and confidence. And we'll do recognizer.predict. And what do we predict? Well, we predict the region of interest. Right? So the ROI gray. That's all we're predicting. Because again, we use the region of interest with the training. And we have labels. So basically what this is saying is giving us the label back and the confidence that it is. Now, I've mentioned that this is not necessarily the best way of doing this. So during my tests, the confidence level varies quite a lot. And even with the accurate image, or even with more images, the confidence level doesn't seem to be accurate to 0 to 100. So I'm actually not sure what this confidence level is supposed to be because it does go over 100. So I'm really curious to see if you guys find research on that. I actually wasn't able to find anything in relation to what that confidence would be. So what I did is I said if conf is greater than or equal to 45, oops, not 54, but 45, and conf is less than or equal to 85, then we'll just go ahead and print out this ID first. Okay, so let's save that and let's run it. And of course now it's just faces. So we're actually implemented with our trainer. And there it is. It's giving me a number. So it's giving me a couple numbers. So let's go ahead and get rid of those. I'm going to save that and quit out of here and then run it again. So really it should only give me a number, one single number. If I'm not in the frame or if I cover it up, it's not going to keep going, right? So let's just start with it covered up. So I have my hand over the webcam and then it's showing a nice zoomed in view of my hand. If I go in front, it recognizes. Close it up, same thing. Okay, cool. So it looks as if it's working. But of course, I have an ID. I don't have a label. I don't have the actual label, right? So I have the sort of training label, which is an ID, but I don't have the actual name, the person's name from that training label. So what I want to get is the name from my pickle, right? So down here, I want to actually load this pickle in. So I'm going to go ahead and copy this value, go back into faces, and we're going to go ahead and import pickle. And in here, right underneath recognizer, I'm going to bring in this pickle. So just paste all that stuff in. Instead of WB, use RB. And now it's just going to be load, and it's going to actually have just the file. Okay, so what this will give us are our actual labels. So the label dictionary. So we'll say labels equals to a dictionary here. And we'll make it empty first, and then I'll do labels equals to that load file. Okay, so I now have my labels in here based off of the label IDs, which is a dictionary. But if you think about it, the label IDs are actually going off of the name. So the lookup is a little bit different than just loading it in here. So I need to actually reverse this lookup. I need to turn this in from being like the person's name equaling to some value or some ID. I need those to be reversed. So to do that, we basically are just going to say labels equals to, and we want the invert of it. So we're inverting the actual labels. So we'll say V:(K) for KV in labels.items. So the original labels, so this is going to be, let's call this OG labels. And this is now our new labels. And of course, this is key value pairs, right? So that's just a quick way of doing that, of inverting it. So now down here with my ID, I'll just go ahead and print out the labels of the ID. So we save that. Let's run it again. And what we see is it's actually saying that I'm the actor who plays Jaime Lannister. Of course, that's not who I am. So there is some issues with our training. So maybe, maybe it's possible that the confidence, I shouldn't have put it less than or equal to 85. So let's just say if it's greater than 85, then we'll print that out. I'm guessing this might make a difference. It might not. But of course, in my initial tests, I actually had me in here working just fine. So I'll go ahead and close that out. So there's definitely some things going on here with our recognizer that's just not getting stuff great. So a couple things. It could be the size of these images. I mean, it could think that I actually look like this guy. I don't necessarily think that I do, but maybe that's what the recognizer is seeing. Maybe these images aren't very good representations of what I look like right now. Maybe that's why. So there's definitely some issues with this recognizer, and that's where using something like a deep learned model might make a big difference. What I will do is I will save one of my images with color. So ROI, I'll just go ahead and save that one, and we'll call this 7. So I'm going to go ahead and save this image. So this is obviously an image of me, but it might actually have the frame on there. So let's go ahead and take a look. And we called it 7. And there we go. So what I'm going to do now is I'm going to open containing folder, and I'm actually going to put this 7 image into my trained items. Granted, it's only showing me the region of interest, so there's a chance that this might mess up because it's not giving me the whole frame. And if it does mess up, then we'll have to take a step back and grab that frame. So now let's go ahead and train again. Faces-train, running it. Okay, so it just takes a moment. It's really, really fast. If you do deep learning libraries, they take a lot longer. So now I run faces again, and same results. Still giving me the wrong actual item here. So again, it might have to do with the size of these images. Because of how I'm treating the training data, I actually don't resize these images at all. So that's a problem. That's something that we might still need to improve. But before I do that, I actually am going to put my label on the actual image itself by doing something called put text. So what we're going to use is a font. So we'll say font equals to cv2.font underscore Hershey underscore simplex. And we'll just say name equals to labels and then ID. And then we want to give a color. So again, the same sort of setup we had before. This time I'm just going to use white. So 255, 255, 255. And then the stroke again. And then we just do cv2.put text, the frame, the name or the text that we're actually putting down, the location. I'm going to put it at X and Y. And of course, X and Y has to relate to where the face actually is. And then the font, I believe the font size, so I'm going to leave it at 1, color, the stroke, and then cv2.line underscore AA. Oops. And that should actually handle it for us. You can look up in the docs for the text parameters if you have other ones. So now that I do that, it's still showing me, the other guy. Okay, so yes, incorrect. So now what I want to do is actually fix the images. Perhaps I need to resize the images first and then convert them. So we'll resize it to a specific size, and I'll just say 550, 550. And I want it to scale correctly, so it's not like it's going to distort the image. So to do that, we'll just do final image equals to the pill image. So of course that's this right here. dot resize to that size that I just wrote, and then image dot anti alias. And then of course now my image array is going to be coming off of that final image. So we save that, and I'm going to go ahead and run it. Faces train. Oh, looks like in my tests I accidentally commented that part out again. So going back, it's running, and then it ran, and now faces. It's got a better idea. It's not perfect still, but it's definitely a better idea that it's me. Now, yet again, while it runs, you can see that's me, but it's still getting me confused with other people. Okay, so how would we actually go about making this better? Well, number one is getting better pictures of all of these people, right? So like, I don't think I really look like him, and I don't think I really look like him. So it's definitely confusing me with these two guys, and granted, I don't have that many pictures, but it's never confused me with him. So it's getting that part accurate, and it's also never confused me with her, which was great. Now, I did have to add in some more images. So I even have images of me in here. Although they're not perfect images, they are images of me in this frame. This could potentially help with the results. But in the long run, would you end up using this sort of recognizer in general? Yes or no? I mean, this is fairly straightforward and easy to set up. But again, you're going to want to have more images that will help with the training. And you also want to have your images roughly the same size. So even my resize method here, that works, but perhaps it's not the best way to do the resizing. Perhaps we want to have good solid data from the get-go. And that is one of those challenges with recognition in general, or when you talk about using deep learning or machine learning, the problems come up with the data. The better data you have, the better these results will be. But overall, it's pretty good. I mean, like I'm not upset with it, you know? Like I think it's actually pretty solid. And all I would really need to do from here is snap some of these pictures and then categorize them and then throw them back into my trainer. So then it knows for sure that, hey, these things are me. And I mean, it's doing a pretty good job. It's not great. It's not perfect, but it is pretty good as far as like showing, hey, that's Justin. Cool. So I do want to have a couple more things to just show you generally about this recognition stuff. So the first thing is actually doing eyes. So like actually recognizing your eyes. And I'm gonna go and copy and paste a few things in here just to make it a little bit faster as a final portion. So the eye cascade, that's the eyes right there. I can actually use this to iterate through and find my eyes, or anyone's eyes for that matter. This also is not perfect, but it's pretty good. So if I paste this in here, there's roughly the exact same thing that you've already been seeing. And then you want to do a very similar iteration to what we've seen before as well with eyes. You would do that. And then finally, we would put, some sort of frame around it or some sort of rectangle. By now, you should have an idea of how to do all of those things. So let's go ahead and save that and close out. I have my item running there still, so let's go ahead and run it again. And now you see that it does get my eyes. Maybe not perfectly, but it does get them well. And notice that when I close them, close everything, it should actually get rid of and show that my eyes are closed. So that's something that's kind of interesting. Hey, if your eyes are closed, maybe I need to buzz you or wake you up or something. Okay, so the next thing is actually smiles, and smile is not a whole lot different. So with smile, I'm actually going to just replace the eye cascade because it's basically the same call. So everything in here is roughly the same. So I'm going to replace that, and I'll just call this, instead of eyes, I'll just call this sub items. That's it. And that way I can replace whatever those items are at any time. And so now let's go ahead and run that. And now it's going to get my smile. Notice that smile's even worse. So smile just really doesn't fully grasp it. It gets my eyes, my nose. It's really not that great as far as recognizing my smile. But again, you could break certain things down and use your own third-party recognizer to make this a little bit different and a little bit better. But overall, this is pretty awesome. I mean, think about the things you can do with this. Assuming that you have a lot of images and you have a lot of data, this should be able to actually give us really, really good results. They're not great, but I mean, hopefully following along with this, it's fairly simple to do. I'm going to use an image from the internet from my phone to see how that image does. Okay, so it's looking for me, and then let's see here. It doesn't seem to be recognizing that face. Maybe that picture is too dark. Let's try a different one. Okay, so this is sort of thinking it's me, but most of the time not. Right? So if I get out of the frame, nope, it's looking like it's me. Still thinks it's me. There's a good chance for that. The reason being is that mine has more training data because I have 8 images versus everyone else that has 6. So that's another challenge with this is having just a more consistent amount of data for every single person. So yeah, that doesn't actually show me unknown. And the part of it is, hey, the confidence is only at 45. So let's go ahead and bring it back to being and 85. So I save that and let's run it again. So really with an unknown face, it should probably not even show anybody. Let's try that again. And now here's an old guy with a beard. Right? So nothing. That's Barrison sell me, but it's not even listing anything. So he doesn't look like any of those people, which is kind of cool. So yeah, it does work. It's not perfect, but it's something. So a couple final thoughts. If you were going to implement this yourself, you are going to want to get a lot of images to work off of, right? That way your actual facial recognition is better. Another thing is to consider a deep learning library to actually handle the recognition as well. So if you built in something like that where you have a good amount of data, and it doesn't necessarily have to be that much with the deep learning library, that will probably give you better results. Although the training itself will take a lot longer than what we saw here. And it also doesn't mean that they're going to be perfect results. It just means that they'll probably be better. And when I say perfect, I mean 100% accurate every single time. That's just not that likely to happen. But with deep learning, you'll have a little bit better of confidence with the actual person that's being predicted or the person's name. So there's a lot of things that we can still do with this, right? It's still could be useful for a variety of applications, but it's not really super secure where it's going to be something that you use to authenticate into your computer or authenticate at all. You probably wouldn't use it for authentication, but what you could use it for is something as simple as walking into a room and then boom, your camera starts recording because it recognizes the person. And if I was out of the room, it wouldn't record. As soon as I came in, it would recognize me and then it would start recording. That would, of course, assume that my computer's on and my webcam's going, but it would totally work. It absolutely would, which does have some features of being, a security camera. Whether it actually recognizes my face or not, those are two different things, right? So there's definitely a lot of really cool stuff with this. And in a little bit over an hour, we figured out how we could do so many things. It might have taken you a little bit longer than that to write all the code and keep up. But I mean, if you think about this in terms of what we could do in an hour with OpenCV, what could we do if we had 10 hours or 15 hours with more training data and also using deep learning and all these things? You could probably make a really sophisticated system, assuming you know how, with very little time. And the other cool thing about this is you can actually attach this to something like a Raspberry Pi and place it in different areas. And the Raspberry Pi can run a lot of these things, including trained models from something like Keras. or TensorFlow or PyTorch, you could actually run those things on Raspberry Pi with OpenCV and not be connected to the internet at all and get really pretty solid data as a response. I mean, of course, it's not going to be perfect, but it will be better than random by a lot, as you may have seen here. So I'm really excited. I'm really excited about what OpenCV can do, and I'm excited about what you might do with it. So if you are interested in seeing us build even more advanced stuff on OpenCV, consider subscribing to our YouTube channel, joincfe.com/YouTube. That's where a lot of this stuff is going to live in the long run, because I'm still experimenting with OpenCV myself, so I want to learn more, and the way I do that is with you guys on YouTube. So joincfe.com/YouTube. Make sure you subscribe to get everything, and then also leave a comment when you find something new or interesting, or you're struggling with something in relation to OpenCV. I try to read as many of these comments as possible, and also we do live stream, so I want to help you guys answer questions there. And if you have suggestions and all that, I'm all for it. I realize I've talked a lot today, and you're probably done hearing me. So thanks so much for watching.